Hi, welcome back. So in the last lecture, we went over the slope-intercept form of a line. Now let's take what we know from that lecture to solve a few problems. You'll likely get some problems like these, or some combination of the concepts in these problems. So let's take a look. Let's say in the problem we're given a point where x is equal to 2 and y is equal to 3. They want us to find the equation for 3 different lines. So we're starting at this point, and they've given us 3 different slopes. One neat and useful trick we can use here is to use the formula for the slope of a line and rearrange it as follows. As we'll see in a minute, by solving these problems, we've actually covered the next concept and the next formula we need to memorize or learn. But we'll get to that in a minute. First, let's deal with the problem at hand. So given the point 2, 3, they ask us to find the equation of a line with slope 0. Now, since the slope is 0 and we're starting at point 2, 3, we can draw on knowledge that we've already learned. We know that the slope represents the rise over run. A slope of 0 means that there is no rise for every unit of run. So we know that for every change of 1 on the x-axis, y doesn't change at all. So we can simply plot points along the x-axis in the negative, positive direction or at 0, and the y values of those will always be 3. So if we take this version for the equation of the slope of a line that we saw earlier and rearrange it, what we can do is fill in the value for the slope which is given to us, and we can use one of the points. Remember, to find the slope of a line you obviously need to have 2 points, but here they've only given us 1. But we can still use that to our advantage. So if we multiply x minus x sub 1 and then rearrange, what we end up with here is y minus y sub 1 is equal to m times x minus x sub 1. Since they've given us a slope of 0, we can fill that in here. And that basically reduces the entire right side of this equation to 0, because anything multiplied by 0 is 0. Since y sub 1, which is the only y value we have here, is equal to 3, the left side of the equation becomes y minus 3. And finally what we're left with is y minus 3 is equal to 0. Adding 3 to both sides isolates the y on the left side, and what we get is y is equal to 3. Now, on an exam or quiz, sometimes you have to be careful with the language they use. And if you're not sure, it's always better to err on the side of caution. So if they want you to write this equation in slope-intercept form, I would leave the answer you have here, or what you could write is y is equal to 0x plus 3, and that puts it in the y is equal to mx plus b form. Okay, let's do the same thing with the same point, but this time we're going to let the slope be equal to 1. We've rearranged our equation, and we filled in the value of m for the slope as 1. We're dealing with the same point, so we can fill in those values again. So what we have is y minus y sub 1, which we know is 3 from above, and we know from above that x sub 1 is 2. Since the slope is 1, we're left with x minus 2 on the right-hand side, and y minus 3 on the left-hand side. If we simplify this equation as we did above, we want to isolate y on the left-hand side, so we add 3 to both sides, and that cancels out the negative 3 on the left, and leaves us with y is equal to x minus 2 plus 3. Now I apologize, there's a typo here. There should be an x right here, so it should read what you see above, x minus 2 plus 3. But we know that minus 2 plus 3 is equal to 1. So what this equation gets reduced to is y is equal to x plus 1. And this makes sense. So if you're writing this in slope-intercept form, we have y is equal to mx. In this case, we know m is 1. And we could write that, depending on how much of a stickler your instructor wants to be, and then plus b, which is the y-intercept. And we know from solving that that's 1. If you plot some points and draw the line on the right-hand side, you can see that that's indeed the case. And that brings us to an important point. If you're given a point as above and a slope, I would recommend writing the equation out as far as you can and filling in some x and y values to get an idea of what the line looks like. Typically, I'll at least plot the points -1, 0, and 1 on the x-axis and see what I get for y. This isn't entirely necessary, but it can help sometimes. And so finally, the third part of this rather long problem, we're given the same point, 2, 3, and a slope of 2. So again, we'll take the formula for the slope of a line, and we'll rearrange that so that we can try to get an equation. Since the points remain the same throughout the problem and only the slope is changed, we know that on the left-hand side we'll have y minus 3, and that will equal the slope times the difference in the x values. Since we only have one x value, we know that we'll be getting a formula out of this. So we write 2, because we've been given the slope of 2, times x minus the one x value we have, which is 2. So basically what we get here is y minus 3 is equal to 2 in parentheses x minus 2. Using the distributive property of multiplication, we multiply the 2 by each term within the parentheses on the right side. So 2 times x is equal to 2x, and 2 times negative 2 is equal to negative 4. If we simplify this to get y by itself on the left-hand side, as we've done in previous example, we would add 3 to both sides of this equation. So the negative 3 plus 3 cancels out on the left-hand side, and we're left with just y. And then on the right-hand side, we have 2x minus 4 plus 3. Negative 4 plus 3 is equal to negative 1. So again, we found the equation of the line using the slope-intercept form of a line, and that is y is equal to 2x minus 1. Let's take a break here. When we come back, we're going to talk about the next formula we need to learn, which, as stated before, we pretty much already have. But we're going to see what types of additional problems we can solve using the formula.